guys, today we're going to finish up Chapter 9, Lesson 2. We've already read everything, so we're just going to review and complete a worksheet. I want you to go ahead and get out the worksheet because I'm going to give you some helpful tips, and I want you to be able to write those down. So you need your worksheet and a pencil. It is Chapter 9, Lesson 2. It's written at the top corner, and your vocab words for this are conductor, electric current, and insulator. So go ahead and find that worksheet for me. On the back, you're going to write the essential question. You can hit pause to give you longer to write the question that I'm going to give you in the video. Okay, make sure it fits on the screen here. How is electricity transferred in a circuit? I also want you to give me 2 conductors and 2 insulators. Okay. All right, let's review. For this lesson, you read pages 401 through 405, and I'm going to give you some important things to remember. On page 401, it talks about an electric charge in motion is called an electric current. Spoiler alert, this is on your worksheet. So you need to know that an electric charge in motion is called an electric current. A circuit flows in a loop. Think about that drawing with the flashlight, where our battery was and our light was, and we had that break in there. An open circuit has at least one break. A closed circuit doesn't have any breaks. So when we had our switch flipped off and that gate was open, we had a break in there. The power couldn't get through and our flashlight didn't work. But when we had our switch flipped on, it closed that gap, the power could get through, our light worked. Okay, so open and closed. Make sure you know the difference. On page 402, the flow of electric charges is not the same in all materials. I want you to think about insulators and conductors. A conductor is a material that an electric charge can move through easily. And an example of that might be metals, copper, and gold. An insulator is a material in which an electric charge moves with difficulty. Now, I want you to think about us walking or swimming or climbing, anything. If it's difficult for us to do that, we're going to move more slowly, right? So some examples of an insulator are rubber and plastic. Okay. Page 404, it talks about a circuit having many parts, and the picture is kind of hard to see, so I'm just going to tell you the 4 parts of a circuit, but I want you to look at the picture to make sure you can identify them and tell me what each part can do. So the 4 parts are switch, resistor, wire, and energy source. In our picture on 404, our energy source is a battery, but that's not the only possible energy source. Think about my holiday lights. I was able to plug that into the wall. Okay, let's see. It also talks about a series circuit and a parallel circuit. I want you to be able to tell me the difference between the two. You need to be able to explain that. So think about the series circuit where I took the light bulb out of my Christmas lights and then all of like a whole string of them stopped working. Some were working over here and then everything after that light stopped working. Is that a series circuit or a parallel circuit? It's a series circuit. Look at the picture on page 405. Do you see how it's got the 3 light bulbs and that first light bulb isn't working, but the last 2 are? That's a parallel circuit. It's got more than one wire leading that energy source into there. So the one light bulb that's out isn't affecting the other 2. All right, that's it. All right, so let's look at our worksheet because I'm going to give you some help on this. On page 402, you're going to be able to answer questions 1 and 2. So for 1 and 2, look on page 402. For question 3, I want you to look on page 401. For question number 4, I want you to look on page 404 and 405. I also want you to think about my purple holiday lights and rewatch that video if you need to. For question 5, this is going to be one of those ones that are like the infer questions. They're not directly in the book, so you're going to have to use your noodle. Why would they put, here I have this in my lap. This is my power cord, and there's wires running in here, and it's plugged into the wall, and this is what charges my computer. Why would they put plastic around this for me to touch it? If it was just open wires, would I want to touch it while it's plugged into the wall? Think about that to answer number 5. And question number 6 is going to be found on page 404, and it's list the 4 parts of a circuit and tell what each part does. Good luck.